Welcome to Data Science 1, Probability, Variance. All right, so we're going to have a whole bunch of things in this video that you're going to need to have some idea about. So we're going to talk about the binomial distribution, the Poisson distribution, the geometric distribution. If you don't know about describing distributions, you should go back and do that because we're going to be talking about the variance, which was introduced there. We're going to talk about the mean and the idea of expectation and the video on expectation in general. So you should go back and watch those if you're not familiar with these concepts yet. Okay, so in a previous video, we introduced the idea of variance as a measure of spread of the probability distribution, and this was its formula. So what we did is we took x minus its mean, and we squared it, and then we multiplied it by the probability of that value. Now, then we just add them all up. Okay, so this is really an expectation. If we stare at it, if we let g of x equal x minus mu squared, this is an expectation. See, we can just substitute it in, plug it into there. We end up with the variance, which is what we're going to call this over here, VARX. But notice the formula comes out exactly the same. And that's why we're going to denote this as variance, and it is an expectation. So it's the average squared distance from the mean, which a lot of people are used to squared distances because it shows up in Pythagorean's theorem. A squared plus b squared equals c squared. Those are all squared distances. All right, so let's look at a simple example. So here's my simple example. I have 0, 1, 2, 3 are the values that x can take. Here's the associated probabilities. Notice they sum to 1 because they're a probability distribution. So what I'm going to do is I'm going to fill out this table, and it's going to allow me to obtain the variance fairly easily, just a lot of tedious calculations. So here, what we're going to do is we're just going to multiply x by f of x in this column. So 0 times 0.32, 1 times 0.51, 2 times 0.12, 3 times 0.05, and here are the numbers that pop out. 0, 0.51, 0.24, 0.15. Now, if I add all of these up in this column, this number here is the mean. Okay? Remember, I need the mean, mu, to go to the next column here. So I have 0.9, and this is where it will come from on this next column. So what I do is I just take x minus the mean, square it. X, 1 minus 0.9 squared, 2 minus 0.9 squared, 3 minus 0.9 squared, and here are the values that you end up with. Now, in the next place, I need to take these values that I've calculated and multiply them by the probability, which is found over here. So that's what I'm doing. I'm taking the number from here, multiplying it by the number over here, and coming up with this number, and so on all the way down. And then what I can do is sum them up. So if I add everything up here, I get 0.6300. So mu is equal to the expected value of x, which is 0.9. Sigma squared is equal to the variance of x, which is 0.63. And if you wanted to, you could get the standard deviation just by taking the square root of this number, and you'll pop up with this number. All right, so let's look at something a little more complicated. For the binomial distribution, we played with it before and found that its mean was n times p. Well, the variance, actually, if you go through and do all the algebra on this, the variance is easy to come up with as well. It's just n times p times 1 minus p, which is, I think, pretty easy to calculate given all the things that you could calculate. Okay, the Poisson distribution. If I use the Poisson distribution, or not use it, but have a Poisson experiment that gives me a Poisson distribution, I plug in the formula here. Mu is equal to lambda, which we saw in a previous video. If you work through all this algebra, you end up with lambda. Yes, the Poisson distribution is pretty easy to deal with if you are clear about what you're doing. Do the algebra. All right, so here, geometric distribution. Sorry, mistake there. It's not supposed to be Poisson. Here, the mean is 1 minus p over p in the formulation of the geometric distribution that we are using. And if I take this and square it, do a whole bunch of algebra, that's what these 3 dots means, and you'll end up with 1 minus p over p squared. And this is easy to calculate as well. So I can avoid doing the sum in lots and lots and lots of cases. All right, so what do we know? So the variance bracket x bracket is equal to sigma squared, and the standard deviation is just the square root of that. And they're decent measures of spread of a distribution. Both mu and sigma squared are expectations, and the variance of x requires you to know the expected value. Can be tedious, but has been worked out for many, many distributions using mathematics, and hence a closed form solution may exist for your particular problem. And what we're going to do in the next video is we're going to kind of run down through the distributions we've seen before, put all the information together. That way we can kind of see where we're at in terms of these distributions and the properties. I'll put down their variances, I'll put down their expected values, and any other pieces of information that we can get out of these pretty easily, so that we're familiar with a variety of distributions and experiment types. So we'll see you there in the next video.